Welcome back to the deep dive. We're here to cut through the noise, all that information hitting your feeds, and pull out the stuff you really need.
That's the goal.
And today, we're moving beyond the usual chatbot talk. We're looking at something, well, much bigger.
Yeah, a really fundamental strategic shift happening in AI right now.
We're talking about moving from those simple reactive helpers towards truly autonomous systems. The industry is really starting to standardize this now, calling them AI agents and talking about agentic workflows for orchestration.
That's exactly right. For years, AI felt like an assistant, a reactive tool. You gave it a prompt, it gave you an answer, simple loop.
Right.
But now we're definitely stepping into the era of the AI strategist. These are systems that can actually define their own steps, figure things out, and proactively go after complex, high-level business goals.
And the sources we got today are pretty dense. Very architectural.
They really are. They lay out the blueprint for this whole transition.
So our mission today, for you listening, is pretty critical. We want to give you the right words, the right vocabulary, and the architectural picture to really grasp the strategic difference between those AI assistants we all know and these emerging AI agents. We'll also need to break down the, 5 tiers of intelligence?
Yeah, 5 distinct types.
Okay. And how they work together. That's orchestration, right?
Yeah.
That tackle complex goals. And crucially, how they actually talk to the outside world using these new protocols.
And look, this isn't just theory. This is really the plumbing of modern business automation. Seriously, every major company is building their future operations on these ideas right now.
So understanding this architecture is key.
Absolutely. If you can clearly talk about agentic architecture, you're in a much better position to, guide those strategic conversations in your own organization.
Okay, let's dive in. Let's unpack this strategic shift, starting with that core difference. Right, let's nail down the difference. AI assistant versus AI agent. Our research uses this really helpful management analogy. It's like the difference between, say, a reactive assistant and a proactive strategic manager.
That analogy is spot on, I think. Think about the AI tools you probably use daily: ChatGPT, Siri, Alexa. Those are the AI assistants.
Okay.
They're reactive helpers. Their job is basically managing appointments, executing tasks you clearly assign. They just wait for a specific command, a prompt.
And only then they act.
Exactly, only then. And you, the user, have to constantly steer the whole process.
So if I'm using an assistant, it's this back and forth loop, right? I prompt, it answers, then I have to figure out the next step, write a new prompt, wait for the new answer. I'm essentially the manager of the process.
Precisely. They're great for certain things: organization, answering basic customer questions, maybe generating some content, but only if the prompts are really clear and step by step.
Makes sense.
And, the way we improve them reflects that reactivity. You either do prompt tuning, basically tweaking the model's settings to get better at a specific type of task, like summarizing legal docs, or you do fine-tuning. That's where you actually train the underlying LLM with tons of specific examples, like feeding it thousands of correctly formatted expense reports for your company so it learns that exact template.
So it gets really good at repetitive, precise tasks.
Right. But the system is still fundamentally waiting for your command, waiting for permission.
Okay, so let's pivot. The AI agent, the proactive strategist. What's the core mental shift here? How does it go from helper to manager?
The big shift is from task orientation to goal orientation. An agent is like that strategic manager who's actively looking for new opportunities, acting in the client's best high-level interest.
Right.
You give it just one initial, maybe even vague high-level prompt, something like optimize our logistics supply chain for the next 6 months, or find a new market for product X.
And the crucial part is it doesn't come back asking, okay, what first?
Exactly. It doesn't ask what to do next. It goes off and figures out the entire execution strategy by itself.
So if the assistant needs that constant human dialogue, the agent is defined by its ability to generate its own workflow.
Yeah.
Takes a complex, maybe ambiguous goal, and autonomously breaks it down into logical, manageable steps.
Precisely. And its core capabilities really define this shift. First, there's initiative, it acts first. Second, autonomy, it makes independent decisions within its boundaries. Third, logical reasoning, finding the best path forward.
Okay.
But maybe the biggest strategic difference is resource utilization. Assistants rely on the context you give them. Agents, on the other hand, actively seek out and use external data and tools. They'll call APIs, check databases, run code, whatever it takes autonomously to reach that goal.
That sounds like it needs a memory, though. Like a real memory that lasts longer than just one conversation. If it's optimizing logistics over 6 months, it can't forget what happened last week, right?
Absolutely critical. A key advanced feature for these agents is persistent memory. They're designed to remember past actions, successes, failures, and use that accumulated knowledge to continually refine their future independent decisions.
That's huge for business.
It really is. Imagine an agent optimizing cloud spend. With persistent memory, it can learn over months, not just hours, which virtual machines are actually the most cost-effective. It becomes way more valuable and scalable because it doesn't need constant human hand-holding to remember the landscape.
Yeah, the contrast in application becomes really clear then. Assistants are great for, routine support, chatbots maybe whipping up a quick code snippet,
Standard stuff.
but agents, they're for the strategic challenges, the dynamic problems, the situations where the solution isn't obvious, like automated trading, real-time network security, optimizing marketing spend based on fluctuating results.
Exactly. But we do need to be really clear about the limitations. That autonomy brings its own set of challenges. Both assistants and agents can suffer from what the sources call brittleness. Basically, if external conditions change unexpectedly, maybe an API goes down, or if you tweak the prompt in a way it didn't anticipate, the whole system can become fragile or just, well, break.
And the agents specifically, because they're acting alone, they carry some extra risks.
They do. Because they're generating their own steps, they can sometimes get stuck in inefficient feedback loops.
Okay, what does that look like?
It's kind of the AI version of a manager just constantly reorganizing their desk instead of doing the main project. The agent might get stuck optimizing some minor intermediate step, just spinning its wheels, trying to self-correct something trivial.
Wasting time and compute cycles.
And resources, yeah.
Yeah.
Which leads to the next point, inherently high resource consumption. They're constantly running complex decision processes, exploring options, calling multiple external services. It adds up.
Okay.
But probably the biggest management headache is the inherent unpredictability. Because they design their own workflows, they might take paths to a goal that you just didn't foresee.
Like an unintended consequence.
Exactly. You might ask it to optimize quarterly profit, and it decides the optimal path is, I don't know, eliminating your entire mid-tier sales team to slash costs. Mathematically correct, perhaps.
But strategically disastrous.
Right. Which is why, even with autonomy, reviewing the output, especially for high-stakes decisions, is still really advisable. You can't just let it run wild without checks. Okay, so far we've kind of lumped all agents together. But to really manage or, build these systems effectively, you need to understand that they're not all the same.
Right, there are levels to this.
Definitely. They differ quite a bit in their intelligence, how they make decisions, and how well they can interact with and model their environment.
And our sources break this down neatly into 5 tiers. It's like a ladder of increasing complexity and capability, right? Moves us beyond just saying AI agent.
Exactly. It gives us a precise way to classify what we're dealing with. Let's start at the bottom, most basic. Type 1, simple reflex agents.
Okay. Simple reflex.
These are the simplest you can get. Their action is based only on the current state of the environment. Think basic condition action rules. If this, then that. They see the world right now and they react instantly.
Let's use that supply chain manager example again. How would that work?
Perfect. So a type 1 inventory agent. Rule is simple. If inventory quantity drops below X, that's the current state, then order more. That's the action.
Super fast, but sounds limited.
Very limited. It has zero memory. So if the incoming shipment is delayed, maybe there's a storm, a dynamic change, the agent just keeps placing the same order over and over again. It literally can't remember that the last 5 tries failed because it only sees the current low inventory. It just repeats mistakes.
Okay, that obvious limitation only living in the present, that leads us straight to type 2, model-based reflex agents, adding some memory.
Exactly. Type 2 adds an internal model or, a state. This memory lets it track parts of the environment it can't currently see. It gives it a more complete picture.
So our supply chain manager.
Yeah, doesn't just look at the current stock level. Its internal model tracks how the world has changed, maybe remembers its own past actions. It might remember, say, that the last order took 7 days to arrive or that 3 key suppliers are currently listed as offline.
Ah, so it's still reacting to current data, but the reaction is informed by a bit of history stored in that model.
Precisely. It tracks the unobservable state. It's smarter than type 1 because it won't just keep ordering if its model shows the transit status hasn't updated. It moves from purely present moment reactions to reactions based on a short-term informed perspective.
Okay, type 1 reacts to now, type 2 reacts based on recent memory. Tech 3, Goal-based agents. This sounds like where true proactive strategy starts.
This is a big jump. In Type 3, those rigid if-then rules get replaced with explicit, defined goals. The agent uses its internal model, but now it uses it to simulate the future results of different potential actions.
So instead of programming if X do Y, you program achieve goal Z.
You got it. For our supply chain manager, the goal isn't just order stock when low, it becomes something higher level, like maintain a 99% order fulfillment rate.
And it figures out how.
Yeah, it simulates different paths. Should it pay extra for expedited shipping? Should it switch to a backup supplier, even if they're pricier? It chooses the sequence of actions it predicts will lead to achieving that defined end state, the 99% fulfillment. It's less concerned about how it gets there, just that it reaches the goal.
That makes sense. But wait, if Type 3 is happy with any path that hits the goal, that might not be the most efficient or profitable path. Why do we need another layer, Type 4, the utility agent? If the goal's met, isn't that enough?
That's a really sharp question, and it gets right to the heart of why Type 4 utility-based agents are strategically necessary, because success often isn't just a binary yes-no.
Okay.
A goal-based agent, Type 3, might hit that 99% fulfillment, but maybe it bankrupts the company doing it by only using hyper-expensive overnight shipping. Type 4 agents don't just pick a path to the goal, they pick the best path. They do this by assigning a utility value. Think of it as a score for preference or happiness or profitability to every possible state they could end up in.
So the decision logic changes from just reaching the goal to maximizing expected utility, finding the optimal outcome.
Yes. For the supply chain agent, the utility function might be complex. Maximize profit margin while also maintaining fulfillment rate above 95% and minimizing warehousing costs. It's constantly balancing these competing demands.
So it might choose a path that only gets 97% fulfillment if that path gives a way better profit margin than the one hitting 99%.
Exactly. It's moving beyond just did I succeed into how well did I succeed. It's about optimization, not just satisfaction.
Which brings us finally to the most adaptable, Type 5, learning agents. These aren't stuck with their initial programming or utility function. They actually improve over time based on experience.
They're the ultimate strategists, really. They have 4 key components working in these continuous feedback loops. There's the performance element. That's the part choosing the action, like trying a new supplier.
Oh, yeah.
Then the critic observes the outcome. Did that new supplier deliver on time? Was the quality good? It compares the result against the performance standard.
Then the learning happens.
Right. The learning element takes the critic's feedback and actually adjusts the agent's underlying strategy. This is often done through reinforcement learning, rewarding good outcomes, penalizing bad ones.
And the fourth part, that stops it getting stuck doing the same good enough thing forever. The problem generator.
That's the key to real innovation. The problem generator proactively suggests new, untried actions, things the agent hasn't done before, just to explore the environment and see what happens.
So it experiments.
Exactly. Our supply chain agent might try sourcing from a completely new, untested region, not because its current strategy demands it, but just to gather data, to see if it can learn a potentially superior way to operate. This continuous, deliberate exploration is what makes Type 5 the most powerful.
Understanding these 5 types feels crucial, because when we get into orchestration next, we're talking about coordinating teams that might have all these different types working together, right? A simple Type 1 doing quick checks, maybe a Type 4 optimizing the overall strategy.
Precisely. You absolutely need to know your players before you can manage the team.
Okay, so we've got these agents getting smarter and more autonomous, but like you said, even a brilliant Type 5 agent can't handle massive, complex business problems alone. That customer, quote, example in the sources, that needed a whole team.
Right, and that's where orchestration comes in. It's the framework, the methodology for getting these specialized agents to work together effectively.
The goal is to break down those silos, right? The fragmented AI ecosystem, as the sources put it. Make sure the specialists collaborate efficiently towards one big objective.
Exactly. And to manage this collaboration, you typically need another specialized agent.
The orchestrator agent. Like a conductor.
Good analogy. This supervisor agent doesn't do the actual work itself. Its job is to monitor the overall workflow, ensure the teamwork is smooth, and crucially, route the right tasks to the agents with the right skills. Frameworks like Microsoft's Group Chat Manager idea embody this concept.
Now, I think it's really important here to draw a clear line. How is this agentic orchestration different from older automation tech, like, say, robotic process automation, RPA? People often blur those lines.
That's a vital distinction and, yeah, a common point of confusion. RPA is fantastic for automating tasks in highly structured, predictable environments.
Like data entry from forms.
Perfect example. RPA needs a precise step-by-step process map. If the form changes, if the website layout shifts, the RPA bot usually breaks. It relies on explicit triggers, structured data like reading specific fields, key value pairs. It's rigid, deterministic, not very adaptable.
Okay, so agentic orchestration is different because of agency.
That's the key word. Agency is the power of the software agent to use its reasoning, its internal models, its persistent memory, to execute actions at its own discretion. It can fill in the gaps when a process is ambiguous or changes slightly. It adapts.
Let's make that concrete with the example from the sources. Creating that complex commercial customer quote, the one that needs sign-off from sales, finance, and product management.
Yeah, trying to do that with RPA would be a nightmare. You'd need thousands of brittle, hard-coded rules, checking product compatibility, applying the right legal terms for that specific region and product combo. If anything changes new product, new regulation, the RPA script likely fails.
So how does the agentic approach handle it? Delegation.
Exactly. Delegation and specialization, coordinated by a master agent or orchestrator, it gets the high-level goal, create quote for client Y. Then it brings in the specialists sequentially.
Okay, step one was CRM analysis, getting the basics right.
Correct. The master agent activates two specialists. First, an assessor agent confirms this is the right process step. Then, a data collector agent pulls the necessary customer master data, maybe purchase history, related documents from the CRM.
And once they're done,
Their job is finished. They pass the crucial info, customer ID, history, etc., into a temporary cached context like a shared digital whiteboard, and they're dismissed. Keeps things efficient.
next up, product analysis. This sounds like where the LLM's reasoning really kicks in, beyond just simple lookups.
Definitely. The master agent calls in agents 3 and 4. Agent 3, the SKU interpreter, figures out what products the customer actually asked for. This might involve understanding natural language from an email or chat.
Not just reading a list of codes.
Right. Then agent 4, the validator, checks if those requested products are actually compatible, do these parts work together, but crucially, it also checks the proposed configuration against higher-level business rules. Are we hitting quarterly sales goals for this product line? Are there inventory constraints? It's applying strategy, not just reading a spec sheet.
Got it. Then we move to the compliance checks, the stuff needing external services, financial and legal review.
Agents 5 and 6 take over. Agent 5, the calculator pricer, calls out to external finance APIs to get the precise current pricing, applying any relevant discounts or taxes for that customer and region.
Real-time accuracy.
Yep. Simultaneously, Agent 6, the legal reviewer, connects to legal service APIs or databases to pull in the exact applicable general terms and conditions, GTCs, for that specific transaction. Again, all this complex, validated context pricing, legal clauses, product config gets added to that shared cache.
And finally, putting it all together. Assembly.
Agent 7, the format, steps in. Its only job is to take all the gathered, validated pieces from the cache, the customer data, the product list, the pricing, the legal terms, and compile them into the final, compliant, properly formatted, quote, document.
Wow. Okay, so that delegation model, specialized agents, caching results, that's the core of how this scales.
That's the defining mechanism of scalable agentic orchestration, yes.
That model also maps really well to another practical system in the sources, the triage agent system. Using that emergency room analogy, assess, prioritize, route.
Yeah, that triage architecture is a fantastic blueprint for automating complex operational workflows. Think customer service escalations, IT incident response, insurance claim processing, places where you have high volume and needs consistent prioritization.
And it uses 3 specialized agents, all capable of tool calling, working in sequence.
Correct, each with a very clear job. First is the intake agent. Think of it as the nurse at the front desk.
Okay, gathering information.
Exactly. It's the conversational interface. It collects the raw data from a customer email, a system alert, whatever, and it connects this to relevant knowledge sources, customer history, past tickets, knowledge-based articles. Its sole focus is comprehensive data gathering.
Then the case goes to the assessment agent, the diagnostician.
Right. This agent's job is pure analysis. It takes the info from intake, diagnoses the actual problem, maybe does some research using its tools, and assigns a concrete priority level: low, medium, high, based on predefined business rules, risk factors, urgency.
Okay, makes sense. And the final step is the routing action agent, the executor.
This is the decision maker. Based on the assessment agent's priority, it executes the right action. Maybe it sends an automated email reply, maybe it creates a work ticket in another system, maybe it routes the case directly to a specialized human team.
But there's a unique function here that adds a lot of value.
Yes, this is key. The routing action agent often has visibility into all the active cases currently in the system. So when a new, maybe high-priority case arrives, it doesn't just route it. It can reevaluate the relative priorities of all the existing cases in the queue.
Ah, so it can dynamically shuffle the queue based on new information, like case A suddenly becomes more urgent because this new related case Z just landed.
Exactly. That real-time reprioritization is what delivers the speed, consistency, and scalability, especially in those high-volume, constantly changing environments. It prevents things from just getting stuck in a simple FIFO queue. Okay, so we know how individual agents think. We know how they collaborate through orchestration. Now we need to understand how they actually talk to the outside world.
The nervous system, you called it.
Yeah, because fundamentally, LLMs have limitations, right? Their knowledge is stuck at their last training date, and they have a limited context window. They can't just magically access real-time data or trigger external actions without a bridge.
And the traditional way, just basic tool calling, it works for simple things. But the research shows it really starts to break down with these complex, autonomous, orchestrating agents.
It really does. The core problem is that the LLM has to tell the application which specific tool or API to call, and translating the LLM's fuzzy intent into a precise function call is, well, error-prone.
What kind of errors are we talking about?
We see three main types of failures. First, hallucination. The LLM literally just makes up a tool name or function signature that doesn't actually exist. It's guessing.
Okay, that's bad.
Yeah. Second, poor selection. The LLM picks the wrong tool. Maybe it defaults to a slow generic web search when it should have used a specific internal database API just because the tool descriptions weren't clear enough about when to use which one.
And the third sounds like an operational nightmare. High complexity and maintenance.
Absolutely. Every time an external API changes, maybe a parameter name gets updated, the developer has to manually go back and update the tool definitions inside the agent's code or configuration. It's time-consuming, expensive, and a major source of production bugs.
So the industry needed something better. Purpose-built protocols. Let's start with MCP, the Model Context Protocol. From Anthropic, right? This one sounds like it's designed for AI.
It is. MCP's whole philosophy is getting the LLM to understand the tool's purpose, going beyond just the structural definition. It uses these naturally descriptive concepts, tools, resources, prompts that the LLM can interpret semantically. It understands the intent.
And the killer feature seems to be runtime discovery.
That's the game changer. Instead of having static, hard-coded tool lists, the agent can connect to an MCP server and dynamically ask what tools are available right now. It uses a command like tools list.
And the response isn't just code.
No, it's not just a function signature. It gets back a natural language description like, use this tool when the user asks for the current weather forecast, but not for historical weather data. This lets the agent adapt on the fly to new tools or updated descriptions without needing the LLM itself to be retrained or the code changed.
How does it technically work?
Under the hood, it uses JSON RPC 2.0. That's text-based, which is great because it's human-readable, makes debugging easier. But the downside is, text is verbose. It sacrifices some performance for that clarity.
Okay, so that performance sacrifice leads us directly to the other major player. gRPC, Google Remote Procedure Call. This one's about speed.
All about speed. gRPC comes straight out of the high-performance microservices world. Its entire design is optimized for maximum efficiency and scalability.
How does it achieve that?
Instead of sending text like JSON, it uses highly efficient binary protocol buffers, or protobuf, usually over HTTP2.
Binary is much faster to process than text.
Way faster. The messages are smaller, they parse quicker. Plus, HTTP2 brings features like multiplexing, sending multiple requests and responses over a single connection without blocking and streaming. If your orchestration engine is making thousands of internal tool calls every second, gRPC is probably the engine you want driving it.
But there's always a but. gRPC has the opposite problem to MCP, right? The semantic gap. It's fast, but it doesn't understand why it's being called.
Exactly. gRPC gives you the method signatures, the data types, the how to call the function, but it provides zero semantic context, no information about when or why the LLM should choose that function.
And since the LLM thinks in terms of intent,
You need a bridge. This usually means building an expensive custom AI translation layer or adapter. This piece of software sits between the LLM agent and the gRPC client, and its job is to translate the LLM's probabilistic intent, I need the latest sales figures, into a specific deterministic RPC call. Execute sales API. Get latest figures with parameter region EU.
So you add architectural complexity to build that translator, but the payoff is raw speed during execution.
It's the classic performance versus semantics trade-off. MCP gives you understanding, gRPC gives you speed.
Okay, so that covers communication within an organization's system or from an agent to external tools. But what about agents from different companies needing to collaborate? Like a travel agent from company A needs to talk to a hotel booking agent from company B.
That requires a standardized protocol for external collaboration, and that's the purpose of A2A, the agent-to-agent protocol.
Designed for third-party interaction.
Precisely. It provides a standard way for these autonomous agents, potentially built by different companies, to work together. The workflow generally has 3 stages. First is discovery.
How do they find each other?
The client agent finds the remote agent by looking up its agent card. This is basically a public JSON metadata file. It describes the remote agent, its identity, what it can do, its capabilities, its network endpoint URL, and, very importantly, its security requirements.
Okay, so stage 2 is authentication, based on what the card specified.
Correct. Ensures secure communication. And stage 3 is the actual communication. This typically uses JSON RPC 2.0 again over HTTPS for security. It supports a standard request response model for quick interactions.
But what about longer tasks, like waiting for a human approval step?
That's where A2A includes support for service end events, or SSE. This lets the remote agent keep an open connection back to the client agent and push status updates as a long task progresses. Things like still awaiting manager approval or booking confirmed keeps the client informed without constant polling.
And there's a key strategic benefit here regarding privacy. Opaque agents.
Yes, that's crucial. A2A allows agents to collaborate, exchange the necessary high-level data to get the job done without revealing their internal proprietary logic or their underlying training data to each other. Company A's travel agent doesn't need to know how Company B's hotel agent works internally, just that it can fulfill the booking request, protects intellectual property and sensitive data.
So putting it all together for someone actually building these systems, what's the practical recommendation on using MCP versus gRPC?
Well, the emerging consensus, especially for robust, high-volume production systems, seems to be coexistent.
Using both?
Yeah. Use MCP for that crucial semantic discovery layer, the brain, that intelligently figures out which tool is the right one to use and why. But then, for the actual high-throughput execution, the motor making potentially thousands of calls per second in the back end use gRPC to capitalize on its raw speed and efficiency. You essentially combine the semantic clarity of MCP with the performance optimization of gRPC. Best of both worlds. Hashtag tag outro.
Wow. Okay, that was quite a journey. We've gone from the simple reactive assistant all the way through these 5 tiers of increasingly intelligent agents, unpacked how they collaborate in orchestration, and now mapped out the communication protocols like MCP and A2A that form their language.
It's a definite, clear strategic shift. The focus is undeniably on maximizing autonomy and utility within these systems.
Yeah, the sources really emphasize that growing sophistication, especially the utility-based and learning agents, and the sheer complexity of orchestration, master agents potentially delegating dozens of tasks.
Which leads to a really interesting, maybe slightly provocative final thought for you, the listener, to mull over. If we're increasingly relying on protocols like A2A to manage these collaborations between specialized agents, agents that are designed to be opaque black boxes, each maximizing its own defined utility function.
Okay.
What happens when the collective outcome of all these autonomous, opaque interactions, where maybe no single human actually saw the entire chain of logic, starts to drift away from the high-level human governance or the ethical standards we thought we set?
How do we ensure alignment when the process governs itself?
Exactly. What architectural safeguards do we need to build into the orchestrator itself or the overall system to maintain that crucial human oversight and strategic alignment, even when the underlying execution is fully autonomous and potentially inscrutable?
That really is the frontier, isn't it? Managing strategy when the employees are self-directing AI.
It's the big question going forward.
A perfect place to leave it for today. Thank you for diving deep with us. And for you listening, maybe your next step is to think about your own daily workflow. Which of those 5 agent types do you see or interact with? And just as a thought experiment, how might you design a simple triage system intake assessment, routing for your own tasks and priorities.
Yeah, applying the model is a great way to internalize it.
Absolutely. Thanks for tuning in to the deep dive.